Hello, this is Sean Luck, your favorite calculus teacher at www.free-academy.com. Today, we're going to be doing problem 32 out of Chapter 3, Section 4 in Anton Calculus 7th edition. Now, I really like this problem both from a teaching perspective and from a practical perspective because this is something that you could possibly come up with in real life if you're doing some calculus, trying to apply some calculus to real life. And the problem states is you have a plane that's flying 3,800 feet above the grounds. And the question is asking us, how does S change when the plane is at about 30 degrees, when theta is at about 30 degrees? What is the rate of change of S when theta is equal to 30 degrees? Now, I've already written out here hypotenuse and opposite. And you should see in any problem where you have both the opposite side from the angle and the hypotenuse, you need to think, hey, this is a problem is going to require a sine, because cosine is the measurement on the base, which would be the ground in this situation. So we have the value for the opposite angle, that's equal to 3,800. And we also have the value for the hypotenuse, that's equal to S. So now we have two different variables here, S and theta, and a constant. Let's manipulate this formula into something we can do the derivative on and then go from there. Now we're going to cross multiply to give us S times the sine of theta equals 3,800. Now we'll divide through sine of theta to get S equals 3,800, 1 over sine of theta, which is equal to cosecant of theta. Now it should be fairly explicit what we'll do next here, but just in case, let me rewrite this as F equals 3,800 cosecant of x. Now you have a function and you have a variable. So this is a situation where you can easily take the derivative. I'm going to proceed with the s and the theta because that's what's in our problem here, and we'll take the derivative of s with respect to theta. And this will give us 3,800, because that's a constant, doesn't come through in our derivative, times the derivative of cosecant of theta, which if you recall your formulas is equal to negative cosecant of theta times the cotangent of theta. So S prime equals negative 3,800 times the cosecant of theta times the cotangent of theta. Now that's our value for the derivative, but in the problem what it said is find how S changes with respect to theta and then find it for theta equal 30 degrees, which I did not have written down here. Theta equal 30. So now we have S prime and we have 30 degrees. Let's plug 30 degrees into our equation here, and then what we will get is the result of the rate of change of S. So S prime is equal to negative 3,800 cosecant of 30 degrees times the cotangent of 30 degrees. Now if you have a calculator handy, you can plug this in for yourself and verify the answers. I did it before starting this lecture here. The cosecant is equal to about negative 1.012. It's got more terms than that, but truncated them after 3 decimal places. Cotangent is equal to negative 0.156. So if you take negative 3,800 times negative 1.012 times negative 0.156, that's going to equal about negative 600.375. So this plane, when it's 3,800 feet off the ground and it's an angle of 30 degrees away from our points here, the change in the hypotenuse is going to be negative 600. So our hypotenuse is shrinking just like we would expect it to. That is our answer to this problem here, and I think this is very illustrative for education purposes. If you guys have any questions, send them in. Hope this is helpful for you.